let's see where we stand with this. Tomorrow we're going to start looking at when these are zeros. That means this, in fact, is a factor. It is a true factor. So from here, I can figure out the other factor of this. This is my other factor. If I take these and I multiply them back, I get what we started from. Now, a good check, especially if you forget to divide if you factored out anything, is always check your front end and your first ones and your last ones. Generally, if your first ones and your last ones are good, the middles probably work. But at least check the first ones and last ones and make sure those check. It's just a quick check for those. Good? Stop me if you have any questions. Sometimes synthetic division is a little bit tricky. But once you get the hang of it, it's so much easier than long division. So this is a factor, don't forget. In your factors, you set to 0. So this is called a root. So you want to divide by the root. And we divide, and we come to this. Now, God bless you. This again had a 0, which means, in fact, God bless you, that is a true factor. We wouldn't be able to factor that otherwise. And then if we kept on going, we would need one more factor to take out of here to be left with a square, and then figure out the other two. If there's any spots missing, make sure you put a 0 there. Always bring the first one down. If you did it the other way, like Riddy said, she goes this way, and then puts her values there, that's fine too. Whichever way you set it up and it works is fine. That part's not my issue. I don't care which way you guys do it. It means you learned it some way and you learned it well. So, now this guy has all the parts to it. Unfortunately, we're going to have to factor out a 4. I couldn't cut to the chase here. Take this piece, set it equal to 0. Here is your root. Remember, do something with this 4, because at the end, you have to take it out. Now, if you didn't, watch what I was saying. If you did this, 12x squared minus 12x plus 4, and you multiplied it by this, watch. If you just multiplied these two pieces, do you get 4x cubed? So that says something went wrong. Found it? Okay. So something went wrong. So always check first and last, and that kind of helps you out there. So don't forget, once you do this, divide this by 4. If there's a remainder, don't divide the remainder by 4, though. If there was. Just the factor part. And then if we wanted to, we could complete the square, we could use the quadratic, we could find the other factor now, which will be irrational. Good? Stop me if you have any questions. Okay? This one was missing an x squared and an x to the 1. 3, 2, 1, 0. Count them down. Yes. Yeah. Good. Remainder, pick it up here. Take the remainder, put it over your denominator. Give me the sign on it, don't forget. And you can make this a separate sign. You could put it next to it. You could say plus this. You could just put the minus there. But make sure you include the sign in it. Wait, say that again?
How you divided the last one by 4?
But that's because the last one, we factored out the 4. Like, I just erased it, but we factored out the 4. This is why we had to divide this by 4. This one, we didn't factor anything out of it. Your leading coefficient when you divide has to be 1. It's kind of like the complete the square thing. You know, when you start, the leading coefficient has to be 1, or you have to factor it. So it kind of leads you into that. But that's the only time you divide, is when you factor something out. We didn't have to factor anything out of this. You're looking at this piece here. If this leading coefficient is 1, you're good to go. Set it equal to 0, find the roots. Okay, this one, a little trickier. Oh, okay, we didn't finish that one. Okay. All right, so let's leave these. Were the rest of them like this? Yeah. Okay, so let's jump to the notes real fast. Actually, I could probably just do it right on this, right? All right, can you just give me the problem that we did in class? Plus, thank you. Okay, so I'm sorry, I forgot we were going to start with this one. So let's do this together. This is when you have three terms down here. Leading coefficient still has to be a 1. And it is. We take the last two terms, that's all we care about. We take the opposite. Because if you, if you set them both to 0 and went from there. So this is going to be a 3, comma, negative 1. Bring out all your coefficients. I have a 1, I have a negative 2, I have 5, and if I count it down, 3, 2, 1, I'm missing something for x to the 0. So I put a 0 here. Now, we start like this. Say, okay, bring down the 1, just like we always did. We're going to multiply left to right. We go from the left, multiply, go to the right. We just have to do this twice. So bring down the 1. 1 times 3, bring it to the right. 3. Now you have another one to do. Negative 1 times 1, bring it to the right of this guy. Negative 1. Stop and just add down the 1 next to the last one that you did. So we're going to add this one down. Wait, what did you ask me?
What you do after you put the negative 1 in the box.
Okay, so you got this far? We took these out the opposite way. We put out all the coefficients. You missed the regular synthetic divide, so this one's going to look a little strange. So we brought down the first one. We have two roots that we're technically going through here. So you're going to say 3 times 1, multiply it to the right. Negative 1 times 1, multiply and go to the right. Stop, God bless you, and add this column down. Then you're going to do it again. This is very different than the regular one. 3 times 1, left to right, go to the right. Negative 1 times 1, go to the right. Now, since we reached the end of this, you're going to add them both down. So if I add this, it becomes 8 minus 1, 7, and negative 1. Now, front end, x cubed over x squared gives me what? X. So this guy has to be x1, x0. This, therefore, will be my remainder. Work your remainder backwards. x0, x1. So I'm just going to put the coefficients here. 1x plus 1 plus, here's my remainder. Okay, so here's my part. Put it in parentheses if it looks a little bit better. I left the 1 there because that's where I pulled this coefficient down. Do you have to leave the 1 there? No, I just did it just in case. You know, if it's a 2, we bring down the 2. So I brought down the 1 for you. So here's your factor. Here's your remainder. It kind of has the same flow. It does have the same flow as your regular synthetic division, but because you have two factors, you have to do it twice. And you always go to the right. Just keep going to the right. And then add down the 1 column. You don't add the both columns down until you finish. We'll do one of the homework ones. We'll do a couple of those. I'll just do 1 or 2. And then we'll have you do 1 for homework. So let's go back up to let's not do that one. Let's do this one. So I have x cubed minus 9 divided by x squared plus 1. This is a good one to do because how many terms really should be in this side down here? 3. We're missing the 0, x to the 1. We're missing x to the 1. So is my leading coefficient 1? Yes. Because it's missing a term in there. So technically, if you have an x squared, you should have an x squared, x1, x0. You should have 3 terms there. I didn't get there yet. We didn't get there yet. Sorry, we're gonna lay that out differently. So our denominator, this leading coefficient is 1, but we have 2 terms we're gonna take. So we're gonna take out the opposite. 0 stays a 0. The 1 stays a negative 1. Now, Anne-Marie was saying the numerator. We got some problems with the numerator. So pull out your coefficients. X cubed is 1. Do you have an x squared? Nope. Put a 0. Do you have an x to the 1? Nope. And you have an x to the 0, negative 9. So this is going to be up here. Work with me. We'll go through this slow. Pull the 1 down. Always pull the first one down. You're multiplying from the left to the right. So from the left, I take the 0. 0 times 1 is 0. I go to the right. I have another factor here, another root. Negative 1 times 1 is negative 1. I go to the right, and I stop. I just add down this column. 0 plus 0, 0. And then I do it again, left to right. 0 times 0, go to the right, 0. Negative 1 times 0, go to the right, 0. This is completed now, so I add both of these down. Negative 1, negative 9. So I look back here, and I look at my front end. X cubed over x squared, what's my result? X. So this guy is x to the 1, x to the 0. This is my remainder. Work it backwards. X to the 0, x to the 1. So I get, again, 1x plus 0. And my remainder says negative 1x minus 9. That's this guy. Over my denominator. Now, I just have to write this as x, right? X plus this mess. And I don't need a 1. Okay? The only difference with the double is you kind of have to go through 2 sets of roots there. Take the last 2 terms. So in our denominator, if it has an x squared and then an x to the 0, you've got to go through and get the space holder in here. You've got to get a space holder, just like you do with the numerator. If there's one that has a leading coefficient, you have to get the coefficient out. Yes. Because this is your remainder. Because normally we have 1 remainder because we only had 1 root to go through. When you have 2 remainders, you usually get 2 roots. So 2 places. So it's like for this one, we take your leading coefficient and we divide them. So I'm going to start with x1, then I go down x0. This one, since you have 2 places, work it backwards. This guy has to be the last one, the x0. Just work it backwards. Because otherwise you say, where do I start? X squared, x1, x3. Start this way and just work it backwards. You're not going to see more than 2 spots there. Because the highest we do is 2 divisors. So it gives us 2 sets of 2 places for our remainder. But if it's just easier, just work these backwards. Because it makes sense, right? This is an x1, this is an x0. I find it easier to work backwards because we kind of don't have to think about it. Good? All right, for homework, you guys are going to try the other 2. There's 2 left on that, right? Yep. Just be careful on this one. This denominator, this is your denominator. Expand it and factor out a 2. So keep in mind that this has to come out at the very end, and there's your roots. take them out the opposite way. Just watch that leading coefficient. You got two things to worry about there. And play with it a little bit. Another good way to check this on your calc is to put this into your Y1. Oh, something's missed. Oh, you just have to put these in the right order. Put this in your Y1, and then this times whatever's left over can go into your Y2. And they should be the same equation.